So here are the 6 trig functions, and here are the 6 derivatives for those trig functions. So this is f of x equals sine x, and the derivative of that is cosine x. And the derivative of cosine x is negative sine x. So with these two functions, these can be differentiated infinitely, because this will just go into a loop of 4. Kind of like how it's I squared, cubed, and to the 4. This one, same thing, but derived 1, 2, 3, 4 times in that loop. So the derivative of cosine x is just negative sine, and then you can continue this loop. And the derivative of tan x is secant squared x. The derivative of cosecant x is negative cosecant x cotan x. And the derivative of secant x is secant x tan x. And the derivative of cotangent x is negative cosecant squared x. And for these two functions, you can prove sine x is the derivative of sine x is cosine x using the limit principle, whereas h approaches 0, and same thing with cosine. And these 4 here, you can just prove it using quotient rule, because tan x is really sine over cosine. This is really 1 over sine, 1 over cosine, and cosine over sine. So if you just apply the quotient rule to these, you'll be able to prove that these are actually the derivatives. Okay, now let's do some practice. So we have f of x equals 2x minus tan x. Find f prime of x. So let's find the derivative of this. So let's split this apart. We know the derivative of 2x is just 2, because when you use the power rule, x to the power 1, 1 minus 1 is just 0. So it's just 2 times 1, which is just equal to 2. And now let's look at the derivative of tan x. And this is just going to equal secant squared x. And remember, there's a negative, so we can just say f prime of x equals 2 minus secant squared x. And that's the final answer. Okay, our second problem we have is f of x equals sine x times tan x, and find f prime of x. So here we see that it's sine x multiplied by tan x. So one function multiplied by another, which should remind you of the product rule. So let's use the product rule to solve this. So we know, let's just say u equals sine x and v equals tan x. And now du, just the derivative of sine x, is cosine x. And the derivative of v is secant squared x. So we have uv du dv. Okay, now let's put it into the product rule, which is just v du plus u dv. So tan x times cosine x plus sine x secant squared x. And you can see here tan x and cosine x can be simplified. So sine over cosine times cosine, it just becomes sine. So we can just say our final answer is sine x plus sine x secant squared x. And that's our final answer. Okay, so number 3, we have f of x equals x squared sine x. And we have to find f prime of x. So here we have another product rule, because it's x squared times sine x. So now let's use the product rule. So let's just say u equals x squared and v equals sine x. And now du is just 2x, dv is just cosine x. And now let's multiply. So we have 2x sine x v du plus u dv, which is just x squared cosine x. And we can't really factor anything else out here except for x, but it doesn't matter all too much. So we can just say this is f prime of x. So for this we have f of x equals cotangent x over 5 minus cosine x. So we see that this is a quotient rule. So let's use that. So u is the numerator, which is cotangent x. And v is the denominator, which is 5 minus cosine x. And du is going to equal negative cosecant squared x. And dv, the 5 is a constant, so it's just 0. And cosine x, the derivative of cosine x is negative sine x. But since there's already a negative in front of it, this just becomes sine x. So now let's put it into the quotient rule formula, which is v du minus u dv over v squared. So v du is 5 minus cosine x times negative cosecant squared x minus cotan x sine x, and it's all over 5 minus cosine x whole squared. And this, let's just say, is equal to f prime of x. And that's the final answer.